All right, let's begin. So how do I solve something like this? Now, if you have any things that if now in the book they have a little bit different, you can have g of x here equal to a constant. If you solve it, set it up that way, you have to follow the book and it mean exactly the same. So, but I have a shorter version that allow you to do that. To minimize or maximize this way, we need to come up with a constant factor so that you can optimize this constraint. So what's that mean? Well, step one, here's what you need to do. Step one, please set up this as f of x comma y, if you have assumed this is only two variable, minus lambda g of x comma y. And this one only work if you set this guy here equal to 0. It doesn't work when this thing here equal to 1 or 2 or anything like that. You want to generate this function here. Let's call this is capital F of x comma y. Capital F of x, okay? Capital F of x comma y. This is your new function. Again, we want to optimize this function with this constraint here. This is called the Lagrange multiplier. This would a way to adjust this constraint so it fit the criteria to maximize this guy. Okay, step 2. Here what you need to do. Step 2, we need to find out what is f sub x is, f sub y is, and f sub lambda. Okay, we need to differentiate each one of this and we'll try to solve this. So here's what we need. We need each one of this is equal to 0. Okay, we set each one of this equal to 0, and what we want to find, what lambda is, what x is, and what y is that satisfy this condition. If we can find this, these will tell you this solution imply that little f of x comma y be optimized. And of course we need to identify, is it a maximum or a minimum? Okay, all right, let's give you a simple example. I would like to find out a product between two numbers. Let's just say I want you to maximize a product between two numbers. Between, okay, two positive numbers. But I don't know what number it is, but all I care about is those two numbers, but with the sum is equal to 20. How about that? Okay, as the sum of those two numbers are 20, and what is the biggest number? So imagine that you can have 1 and 19, 1.5 to 18.5, 2 and 18, and which one give you the largest? So here's an idea. A function that I want to maximize here is a function between two numbers, is x times y. I would like to maximize this. Again, I want x to be greater than 0, y greater than 0. I don't want to be positive number. I don't want it to be negative or 0. And with 0 will give you 0, and you don't want that. Okay, but subject to, okay, x plus y is equal to 20. So if I want to change this to g of x, this is x plus y minus 20 is equal to 0. So this is my g of x comma y. It's a good sense that you keep it this way at all times. So what does this mean now? So here, what is my capital F of x comma y? Capital F of x is little f of x comma y minus lambda g of x comma y. Okay, multiplied by those. So what is this guy? What is this guy? So let's go to the next page. We can talk about this guy. Again, this is the function that we have. Let's see what we can do with this. All right, so that means your capital F of x comma y can be written as x times y minus lambda times x plus y minus 20. Okay, so what I want from here, so after this guy we can solve for those steps. Remember, we want to find out what this guy would be, so that means we'd like to find out what is f sub x. If you take derivative of this with respect to x, I want this to equal to 0. That's equivalent of saying y minus, well, this is lambda. What derivative with respect to x here is 1 y is 0, here is just 20. So this is will give you, I want this to be equal to 0. That's equivalent of saying y minus lambda equal to 0. So that's the first thing that we learn about this guy. So f sub y is equal to 0. That means if I do exactly the same thing here, partial derivative with respect to y here, I just have x minus lambda, partial derivative with respect to y here, you get this 1, and this is 0, imply that x minus lambda is equal to 0. So what is f sub lambda? F sub lambda equal to 0 is equivalent of saying, if I take derivative of this with respect to lambda, this is 0. If I take derivative with respect to lambdas here, this is a constant, so I left with this constant with this minus. So this is minus x plus y minus 20 is equal to 0. Okay? Now, the nice thing about this is we can solve for lambda here. That means lambda must equal to y. This is also tell you that lambda here is also to x. X equal to lambda and y equal to lambda. This is also imply that x must equal to y. Otherwise, it can't be true. Okay? If that is the case, that means this last step here, we said x must equal to y. That means saying minus x plus y. If x equal to y, I can write this as x equal to 20 equal to 0. Or multiply by minus 1, this just left with 2x minus 20 equal to 0. 2 times x, 2 times what is minus 20? That means x must equal to 10. If x is 10, y is 10. Okay? So this is the maximum. It will give you the maximum, nothing else. Nothing else to give you that anything larger than that. Okay? We're going to look at another example. Okay, look at another example. Let's look at the example from the homework assignment. Okay, let's look at the example from the homework assignments. What if you do it in 3 variables? So another example here. Okay, let's look at another example in multivariable function using Lagrange multiplier. So how about if I want you to find out, maximize here your function, the letter f, x, y, and z. So this is the little f, x, y, and z equal to x squared plus y squared plus z squared. Okay, and subject to g of x, and subject to okay, x plus y plus z is equal to 9. Okay, what if this is the case? Can you find a minimum value on here? So it's a minimum value. Now I would not go into yet. We're not gonna tell you when you find this value. I just want you to assume it is a minimum. Now there is a way to test them. We're gonna test them later on. Okay, just make sure you. We're gonna talk about how to test them later on. It's hard for me to explain to you online like this, and why not? Why is it the minimum? So I'm going to tell you whatever the answer you obtain from here. We'll assume that it's a minimum, or you obtain will be the maximum, depending on what the type of question it is. You don't have to show me is it a minimum or a maximum. Okay. Now, again, now you have a capital F of x, y, and z. This is x squared plus y squared minus plus z squared. But this guy here, in order to call it g of x, that means this has to be x plus y plus z minus 9 is equal to 0. So this is your new z plus minus lambda x plus y plus z minus 9 is equal to, it's not equal to anything, just this function. So let me rewrite this function again. X, y, and z must equal to x squared plus y squared plus z squared minus lambda times x plus y plus z minus 9. Okay, so how do we do this? Again, now we have 3 variables, and then we have to know this guy right here, f sub x. You want this to be equal to 0, f sub y, f sub z, and then want each one of this equal to 0. And also don't forget the Lagrange multiplier, f sub lambda is equals to 0. So here, f sub x, this guy here will tell you that this is 2x, and the derivative of this is minus 1, so this is minus lambda. And this is 2y minus lambda, minus 2z minus lambda. And if we take the derivative of this with respect to lambda, this is all 0, so those left with minus x plus y plus z minus 9. Okay, So this is implying that lambda equal to 2x. That's also implied that lambda equal to 2y. That's also implied that lambda is equal to 2z. Now if you notice, for this particular problem here, the x, y must be the same. Okay, x, y, z must be the same. Therefore, if I want this to be 0, this is feel like x plus x plus x. So this is 3x minus 9. Ignore this minus if you multiply both sides by minus 1. Equal to 0. That implies that x equal to 3. Okay, if x equal to 3, then y is also equal to 3 and z is also equal to 3. Okay, so each one of this will give you the minimum value. If you anything else that bigger than that will be bigger. So you pick some other number will give you a larger value. So think about this, if I put a 3 square, 3 plus 3 plus 3 is 9, but 3 square plus 3 square plus 3 square is 9 plus 9 plus 9 will give you, what, 27? But I can also have a different way of getting to a 9. I could have a 4 plus 4 plus 1. If I do that, it's also 9, but 4 square 16, 4 square 16 plus 1 square is 1. 16 plus 16 plus 1 is bigger than 27. So if you choose any other way, it's going to be bigger. So this is a minimum. So okay, at the moment you don't need to show me it is a minimum. All right, let me try to show you other variation. Let me give you another example.